Hello everybody. In this video lesson I will talk to you how we demonstrate organic molecules. There are a number of ways we can demonstrate organic molecules. Let's give an example. Butane. Butane has 4 carbon atoms and 10 hydrogen atoms. We call this molecular formula of butane. Molecular formula of a butane, which demonstrate us butane is made of from 4 carbon atoms and 10 hydrogen atoms. Open structure of butane tells us how these atoms are connected to each other. Carbon may be connected in a straight line. Or there is a possibility that carbon may branch out. Both structures are possible. Okay. Now we just draw the hydrogen bonds. In butane, this is also has carbon atoms, 4 carbon atoms, but carbons are connected different from the above. We call this structure open structure of butane. If carbon atoms are connected in a straight line, we call this N-butane. If there is a branch in connection of carbon, then this is called, this time not normal butane, isobutane. Okay, let's put the hydrogen atoms. As you can see, these two structures are open structure of butane. One is open structure of isobutane. One is open structure of normal butane. In some books, this may be called displayed formula. Okay, let's take this here. This is open structure of isobutane. In open structure, we show all the elements how they are connected to each other. Let's now show the condensed structure of N-butane. Condensed structure, whatever we see connected to carbon, we write this as a condensed form. I'm just starting from left and going to the right. As you can see, this carbon has 3 hydrogen atoms. So I'm just writing this as CH3. Next carbon has 2 hydrogen connected. CH2. Next carbon again connected to 2 hydrogen atoms. I will write this CH2. Final carbon atom has 3 hydrogen atoms. So I condensed all of this hydrogen like this. This is the condensed structure of N-butane. Sometimes, if there is a repeating unit, we may further condense this structure. CH2 is repeating. I could write this like this one. This is the also condensed structure of N-butane. Okay, now let's write condensed structure of isobutane. I will start from the left and then go through light. Okay. This carbon atom has 3 hydrogens connected to it. Okay, next carbon atom is this one. This carbon atom has just only 1 hydrogen. Now there is a branch. This is a branch. I will show this carbon in parentheses. Final carbon CH3. In parentheses, I showed methyl group because that is a branch. This is the condensed structure of isobutane. Okay, now let's write the line structure. Some may call it skeletal formula of an organic molecule. In line structure, we put a dot for each carbon atom. They are connected in a zigzag form where carbon atom makes an angle of 190.5 degrees. Okay, let's start drawing line structure of N-butane. N-butane, I have 4 carbon atoms. Therefore, I will put 4 dots and connect them by a bond. This is a bond, carbon-carbon bond. This is also a carbon-carbon bond. This is also a carbon-carbon bond. The angle between bonds are 109.5 degrees. That's it, very simple. Just remember when you're drawing this line structure, these bonds should have 190.5 degrees. Okay, let's draw line structure of isobutane. This time in a straight connection, there are 3 carbon atoms. I will put 3 dots. And this middle carbon has a branch, 1 carbon atom. As you can see, this is the line structure of isobutane. This one is line structure of normal butane. Now let's draw the 3D structure of N-butane. This time we need to show how these elements are connected to each other in a 3-dimensional way. Let's take N-butane. Okay, 4 carbon atoms connected in a straight line. How this carbon atom, how hydrogen are connected to this carbon atom in a 3-dimensional way? One is facing to us, the other facing backward. This hydrogen is in the front. This hydrogen is in the back of the molecule. If these lines are in the plane of our screen, in this carbon, one of the hydrogen are in the plane, but the other two hydrogen, one is facing to us, the other hydrogen facing to the back. Let's draw this one. I can see these two lines in the same plane. This line and this line in the same plane. One hydrogen is facing, toward us. Facing backward, the other hydrogen. In this carbon, there are three hydrogen. One must be in the same plane with the carbon atom. The other two hydrogen, one is facing toward us, the other one is facing backward. So we call this 3D structure of normal butane. These are carbon atoms. So you can put, if you want, carbon. Lewis structure in this case is equal to open structure of N-butane or isobutane, because all of the valence shell electrons of carbon bonded to hydrogen atoms or carbon atoms shared between these two. That's it. In this video lesson, we have learned how to draw or write molecular formula of an organic molecule, open structure of an organic molecule, condensed structure of an organic molecule, line structure of an organic molecule. In some textbooks, some of the names can be written in a different way. Open structure may be written as displayed formula. Condensed structure may be written as structural formula. Line structure may be written as skeletal formula. That's it.